All right, so I'm going to go over a few of the problems from number 16. First of all, there's just the basic exponent ones, like A, if I have 1/8 to the negative 2/3. There's a number of ways to do this. I would probably get rid of the negative first, and just remember the negative exponent sends, well, generally speaking, it'll send a number to the denominator, but if we've already got a fraction, they're going to switch places. So 1/8 to the negative 2/3 would be the same as 8/1 to the positive 2/3. So if I flip it, I can make it positive, or just 8 to the 2/3. And now remember, if I see 8 to the 2/3, I want to split that up into 8 to the 1/3 raised to the second power, because 1/3 times 2 would give me 2/3. But of course 8 to the 1/3 is just the cube root of 8 squared, and we happen to know that the cube root of 8 is 2, so that's just 2 squared, which is 4. And that's your final answer. Now let's take a look. Let's see, that was A. Now let's take a look at B. If I have the log of 1 over the cube root of 100. Now keep in mind, when you're trying to find a log, you're trying to find an exponent, and you just need to know your base. Now in this case, remember, when there's no base written in, that's our common log, which has base 10. And so basically I'm trying to find what power of 10 is this, or if it helps you, set it equal to x and say this is asking me 10 to what power equals 1 over the cube root of 100. And so without a calculator, I'm just going to try and rearrange this to be a power of 10, which is not so bad because I know that 100 is 10 squared, so that's 1 over the cube root of 10 squared. But the cube root is just a power of 1/3. So that's 1 over 10 squared raised to the 1/3. But when you have a power raised to a power, you can multiply them. So that's 1 over 10 to the 2/3. But then again, remember, when I have an exponent on bottom, I can pull it up and just switch the sign. So that would be 10 to the negative 2/3, and now it's out of the fraction. So boiling down to 10 to the x equals 10 to the negative 2/3. Remember, what I was looking for is this x value, which is my exponent, and so the answer is negative 2/3. Let's see, a similar example would be, let's say in part G, where I have ln of e times e to the a, assuming that's all within the logarithm. Now remember, ln is just another way of saying log with a base of e. So I'm saying e times e to the a is what power of e? Or again, if you like to rearrange it, this would be e to what power equals e times e to the a. But now here, notice you have two powers of e that are multiplied. This is e to the 1 times e to the a, in which case you add the exponents. So that would be e to the 1 plus a, which means now that I got the bases to match, that x I was looking for is the exponent 1 plus a. One more that's a little different is D up here. In D, there was log 32 over log 2. Now don't get confused with the properties of logarithms. If the argument itself were divided, we could split it up into subtraction. But this time the whole logarithm's divided. And if you remember, where we saw that whole logarithm dividing is where we did our change of base property. So let me jot it down. If you remember, if I had log base b of a, we said we could type that into the calculator as log a over log b. So in this case, I'm just going backwards. I have log 32 over log 2 is going to be the same as log base 2 of 32. And that just means 2 to what power is 32, or if you want to rewrite it, 2 to what power equals 32. And so the answer, of course, is 5, because 2 to the 5th is 32.